Alright, we're going to look over the rational functions homework. And so for the first question here, we have this rational function. It says, how do you find the vertical asymptotes of a rational function? So remember, the vertical asymptotes are where we are undefined. So it's setting the denominator equal to 0, because that's when a fraction is undefined. So to find the vertical asymptotes here, we're going to set x squared minus 2x minus 8 equal to 0. And we're going to factor that. So we know x times x, and then we numbers out multiply to negative 8 and add to negative 2. That would be a negative 4 and a positive 2. Set this equal to 0. That tells us that our zeros here are 4 and negative 2, and then those are going to be our vertical asymptotes. Now, how do you know if a rational function has a slant or a horizontal? Well, it only has a slant asymptote if the degree on top of the numerator is greater than the degree of the denominator by 1. It'll have a horizontal asymptote. Okay, so that was the slant asymptote. It'll have a horizontal asymptote if the degrees are equal, or if the denominator is larger. Than the numerator. Okay, so for this particular function, it looks like we are 1 degree larger, so we're going to have a slant asymptote. So we're going to kind of divide this up. Remember, we talked about that this is like having an improper fraction, so we're just trying to take out the whole. So we're going to divide by, this will be x squared minus 2x minus 8. So again, long division. We start and say, okay, x squared times what would make x cubed? That would just be x. And then we'll distribute that to all those guys. That makes x cubed minus 2x squared minus 8x. Then we need to change our sign. So it'll be a minus, a plus, a plus. So we're going to have 5x squared plus 2x. And then we can bring down that minus 8. Then we start that process over again. So we're going to say x squared times what will make 5x squared this time. We're going to say plus 5. And then again, that guy can distribute. So we're going to have 5x squared minus 10x minus 40. Change our signs, minus, plus, plus. And so we're going to get a 12x, and that will be a plus 32. So that's our remainder, because we can't do it again. X squared times something to make 12x. It doesn't work anymore. So that's my remainder. I'm going to write it as a fraction, so over my divisor. And so remember, the whole part is going to be our slant asymptote. So our slant asymptote will be y equals x plus 5, which is a line. So the next question says, what points does r of x cross that slant asymptote? So really that question is, does our original function, which was x cubed plus 3x squared minus 6x minus 8 over x squared minus 2x minus 8, does this ever equal that x plus 5? And so to solve this, I would want to clear out that fraction. So I'm going to multiply by that x squared minus 2x minus 8 on both sides. And that will cancel again. So we're going to be left with x to the third plus 3x squared minus 6x minus 8 equals, if we distribute, we're going to have x to the third minus 2x squared minus 8x. And then we're going to take 5 to each thing, so plus 5x squared minus 10x minus 40. So trying to kind of put together our like terms. Normally, if we have a bunch of polynomials terms going on, we want to make it equal to 0. So I'm going to move my terms over, which these cancel out. And then I also have, notice there's a negative 2x squared and a 5x squared. That's really 3x squared. So if I minus that 3x squared, That's going to cancel that out too. So all those terms are gone. So right now I'm left with negative 6x minus 8 is equal to negative 10x minus 40, which I just realized I left out that negative 8x, so there's still a negative 8x also. So it looks like negative 6x minus 8 is equal to, putting those together, that'd be negative 18x minus 40. So put the x's together, I'll add 18x, that's going to be a negative, oops, not negative. It'll be a 12x minus 8 equals negative 40. Add the 8 over, we're going to get 12x equals negative 32. Divide by 12. It looks like it will cross when x is equal to negative 32 twelfths, which is negative 8 thirds. Okay, and again, what we're saying is when this function here, our rational function, when will it be equal to that line? And graphically, we're saying when do they intersect? It's going to happen when x is equal to that negative 8 third. Okay, moving along here, number 2 wants us to write an equation of a function with the given features. So let's think carefully about how we find these. All right, so a horizontal asymptote of y equals 1. That means our lead coefficients have to be the same, and they're going to have something with a 1. A vertical asymptote of x equals 2, that comes from a factor of x minus 2. And so that's happening in the denominator, because that's when we're undefined. Our y-intercept happens when we plug a 0 in, so we'll keep that in mind. And we have x-intercepts at negative 3, 0, and 1, 0. So those come from x plus 3 and x minus 1, and I'm putting those in the numerator because in order to be an x-intercept, it's when your function value is 0, which for a fraction, it's when the numerator is 0. So those are the points coming from the zeros of our numerator. Now the degrees had to be the same in order to get that vertical asymptote. So that means x minus 2 is actually happening 2 times because we only have one vertical asymptote. So that's the only way that could happen there. And so it looks like so far this is going to be my function, but I want to check that my y-intercept does come out to be negative 3/4. So plugging in a 0 here, we're going to get 0 plus 3 times 0 minus 1 all over 0 minus 2 times 0 minus 2. So on the top, everything will kind of, zeros will go away, so we're going to have a negative 3. On the bottom, we're going to get a positive 4. So we get negative 3/4 like we wanted. So then we would say that our function is this guy. If you wanted to, you could multiply him out. So you could say that this is x squared. Let's see, we'll get a negative 1x plus 3x, so plus 2x minus 3. Over in the bottom, we'll end up with x squared minus a 2x, that'll be minus 4x plus 4. So either one is totally fine. I like to keep it factored just because then you can really clearly see where you're undefined and what your intercepts are. But either way is fine. All right. For number 3, we're going to sketch all of these details and get our graph, just like we were doing in class. So I have a little bit of writing, so we're going to try and go around that. So we'll see how that works out. So I have y equals 0 is my horizontal asymptote. So I'm going to put that in there. My vertical asymptotes are x equals negative 2 and x equals 2. Have a little symmetry going on here. 0, 2 is a y-intercept. Negative 3, 0 and 3, 0 are my x-intercepts, and we're symmetric across the y-axis. See, it's kind of looking the same on both sides. And we pass through 4, negative 1. So 4, negative 1 is going to be down here. So that means that we pass through negative 4, negative 1. Okay, so if I play like connect the dots, I'm looking at that right side, those would connect together. There's no other x-intercepts, and I know that the horizontal asymptote is my end behavior, so I might go down for a bit, but I'm going to have to come back up and get close to that horizontal. And then on the other side of the dot, I'm going to have to just go up and get closer and closer to that vertical asymptote. And it's going to look the same on both sides, so I'm going to have, you can read through this, going up vertically and going up to the y equals 0 line. And then I don't have any x-intercepts in here, so I know that this graph is going to have to go up, and it's symmetric, so it's going to look the same on both sides. So there's a sketch of that guy. That's one possible answer. There might be some others, but that's what I came up with. All right, for 4 and 5, we're straight up graphing them, finding all of those details. So the first thing that we want to find is the vertical and horizontal asymptotes. So to find the vertical, remember we're going to set the denominator equal to 0. And so if you take a look at this, there's no 0 that we can actually plug in that will make this work. You can try and solve and then use the square root property, but you're going to get that imaginary solution. So there are no vertical asymptotes. To find the horizontal asymptotes, we look at the degree. They both have power 2, so then it's going to be 3 over 1. So that means as our x's get really, really big, we're going to approach the line y equals 3. Now we do want to see if we cross that line. So let's set our whole function equal to 3, because that will let us know if we actually do touch the 3. So we're going to clear the fraction first. So to clear that fraction, we're going to multiply both sides by x squared plus 1. That cancels those out, but we have to do it on both sides to balance our equation. So we'll have 3x squared minus 5x minus 2 is equal to, distributing, we'll get 3x squared plus 3. Now I see an x squared in there. It makes me want to make this equal to 0 to try and solve either by factoring or quadratic formula. But when I move the x squared over, it actually cancels out the x squareds. So all I have left is an x. And so I can just solve this. It's just a regular linear equation. Add 2 over, so it looks like negative 5x equals 5. Divide by negative 5. X equals negative 1. So it looks like when x is negative 1, our output would be that 3. So we cross negative 1, 3. We will cross that asymptote. Now we also need to find our x-intercept and our y-intercept. So to find the x-intercept, we set the numerator equal to 0, which will be 3x squared minus 5x minus 2. And that's because if a fraction has 0 in the numerator, it makes the whole fraction equal 0, which would mean our output is 0. So this one we could do guess and check factoring. Because there's a 3 in the front, it takes a little bit more work. So I think I'm going to do our little x thing. So I'm going to multiply 3 times negative 2 is negative 6. Middle is negative 5. So two numbers that multiply to negative 6 add to negative 5. That will be negative 6 and 1. So we're really just breaking apart that middle term. Okay, and so then we're going to factor by grouping. Those first two have a 3x in common. We're left with x minus 2. The next two don't have anything in common. We're just going to put a positive 1, and that'll be left with x minus 2. So we have x minus 2 is the common factor now, and then 3x plus 1 equal to 0. That means my zeros will be, we'll get a positive 2, and we'll get a negative 1/3. So those guys are going to be the x-intercept. So actually, I shouldn't exactly box them in. I should write them as points. They're 2, 0, and negative 1/3, 0. And let's see, what other information am I forgetting? Oh, y-intercept. I'm going to kind of scroll down to the bottom here so I don't draw all over my graph. Y-intercept, remember that is where we touch the y-axis, so that's when x is equal to 0, so we'll find f of 0. And that's going to be, everything can kind of cancel out, except we'll have a negative 2 over 1. So we'll get negative 2. So 0, negative 2 is our y-intercept. So plotting that information, 0, negative 2 is the last thing we found. 2, 0, and negative 1/3, 0 are the x-intercepts. We know our horizontal asymptote is at y equals 1, and we don't have any vertical asymptotes. We do know, I'm sorry, we put y equals 1? I mean y equals 3. Let's get rid of that. All right, horizontal asymptote. It was at 3. X equals negative 1 is where we will cross it. So I'm going to sketch the y equals 3. And then at negative 1/3, we're going to go through it. So if I play connect the dots here, again, knowing that my end behavior is going to get closer and closer and closer to that horizontal asymptote. And this one went through, so it's going to be up above. It's going to look something like that. All right, last guy here. We're going to graph, same thing, finding all those little parts. So starting, vertical asymptotes, denominator equal to 0. If I factor, that's going to be x minus 3, x minus 1. So our vertical asymptotes, really the zeros of the denominator, will be x equals 3 and x equals 1. For our horizontal asymptote, they are again the same degree. So we're going to take that coefficient negative 2 over 1. So we get y equals negative 2. is our horizontal. The next question is, do we cross? That is, does negative 2x squared plus 2x plus 4 over x squared minus 4x plus 3, will this ever equal that negative 2? That's that horizontal asymptote. And so we can try and see if there's an x value where that happens. So we multiply both sides, clear out the fraction. And so on the left side, we're left with negative 2x squared plus 2x plus 4 equals, on the right side, if we distribute the negative 2, we're going to have negative 2x squared plus 8x minus 6. And again, I see x squareds on both sides, so I'm going to try and put those together. I'm going to move this minus 2x squared over, so that way those will actually cancel. And then we're just left with a linear equation, so we're going to put all of our x's on one side. I'm going to move my 2x over, keep it positive. That's 4 equals 6x minus 6. Add the 6 over, we're going to get 10 equals 6x. Dividing by 6, we get x is equal to 10/6, which is really 5/3. So I know right now that 5/3 as an input gets me negative 2 as an output. So that will be where we cross. All right, for intercepts, we have x-intercepts. That's again when our fraction equals 0. So when negative 2x squared plus 2x plus 4 equals 0. There's a lot of 2's going on there. I'm going to actually pull out a negative 2, just so that lead coefficient comes out, and I'm left with an x squared. And that would mean I have a minus x and then minus 2 equal to 0. So this one factors kind of nicer. I have x and x. And then numbers that multiply to negative 2 and add to negative, that's really a 1. That'll be negative 2 plus 1 equals 0. We still have that negative 2. So that's factored completely, but really the only zeros that we have come from these two factors. So we're going to get x equals 2 and x equals negative 1. Those are the points 2, 0 and negative 1, 0 as our x-intercepts. Then for the y-intercept, that's when we plug in a 0 because we're just on the y-axis. So plugging a 0 to everything ends up getting us just 4/3. So 0, 4/3 is our y-intercept. All right, so let's plot this information. So 0, 4/3, I'm going to put that first. That's a little bit more than 1. So I have that y-intercept. My x-intercepts are 2, 0 and negative 1, 0. I'm just kind of working my way back up here. And then I know I cross my horizontal. So my horizontal is y equals negative 2. And I cross it at 5/3. So just kind of looking back, 5/3 is really 1 2/3. So at 1 2/3, I'm at negative 2. So it's like right here. And then x equals 3 is a vertical asymptote, and also x equals 1. Okay, so we're going to play a little bit of connect the dots. So I know these two would come together, and I would have to just go up, getting closer and closer to that vertical asymptote. My end behavior this way, getting closer and closer to that horizontal. Inside here, these will connect, and there's no other x-intercepts there, so it's going to just have to keep going up, and then this guy will have to keep going down. Now on the right side, we really have two options, something going on like this or like this. The problem with the top one is that it would force another x-intercept, and we don't have any more x-intercepts, so it would have to be then the bottom one. So we're going to be living somewhere over here. If you want to check that, you can like plug in and see if a point actually gets you there, because remember, a graph is a set of all ordered pairs that are on the graph. So like maybe if I check what happens when x is 4, so you can plug a 4 in, and when you plug a 4 in to that function, you're going to get negative 2 times 4 squared plus 2 times 4 plus 4 all over 4 squared minus 4 times 4 plus 3. So that's going to be, let's see, 16. That's negative 32 plus 8 plus 4 all over 16 minus 16 plus 3, which ends up being, we'll get a negative 20 on the top and a 3 on the bottom. So that is about, well, not about, we'll just write it as a mixed number, Negative 20 divided by 3 goes 6 whole times. That's 18. So we'll get 2/3. So negative 6 2/3. So when x equals 4, I'm down at negative 6 2/3. So like somewhere right here, which makes sense to where my graph is. So I hope that was helpful.